My name is James Beacham, and I'm a particle physicist at the Large Hadron Collider at CERN, the largest experiment in human history. The thing that brings me here is that there is, in fact, a pretty key philosophical kinship between particle physicists and developers. Particle physicists are kind of like we're hackers of the physical world. We really are, because when we have some observation we make about physics or about astrophysics, about the world around us, and it doesn't make any sense, you want to try to figure out what, how to like approach this question and this problem. And sometimes there's not even a well-defined problem for you to solve. So you have to think to yourself, okay, how could I even, what tools exist in anywhere for me to try to solve this problem? And if they don't exist, you invent them. So for example, if you want to understand more about nature, about why do all the particles around us have the masses that they do, you don't just throw up your hands and say, well, we don't know, and we'll never know. Instead, you say, maybe to address this question, we could build a 27-kilometer circular tunnel on the border of France and Switzerland, 100 meters underground, and fill this tunnel with superconducting magnets that are colder than outer space, and put beams of protons in there and accelerate them to almost the speed of light and smash them into each other millions of times a second for weeks and months and years, and build up the largest unique data set in human history to search for evidence of undiscovered particles that could help answer this question. That takes some innovation and some problem-solving skills to do. And so my favorite, my friends that are also coders and programmers and developers in general, they also have, the best ones have a similar attitude, right? It's like, okay, what does my client need, or what is the problem that they have brought to me? Sometimes when a client comes to you, they tell me that the client sometimes doesn't even know what they need, and so the developer has to think to themselves, okay, what is their task? What is it that they need to address? What is the gap that they're facing between what they're currently doing and what they'd like to do? And the developer then has to figure out a way to get them from A to Z. And sometimes there's no clear path to do that. So developers are also hackers in both senses of the word. The old school programmer hacker, but also hacking, meaning you find any tool that exists to make you solve your problem, to address your issue, and if it doesn't exist, you invent it. One of the other kinships that is between particle physics and developers is that developers are really building the fabric of our existence right now, right? The fabric of our technological, our kind of practical existence. Everything you do is steeped in code. I mean, I'm not the first person to say that, but literally everything you're doing, everything around us right now, well, not everything, but a lot of things around us right now, the way that we interact with the world is absolutely based upon what developers do and what the developers create, what coders and programmers create, and the way that they understand these tools of interacting with the modern world. That's going to define our future. For the research that we do at CERN, because particle physicists, we have to kind of be Swiss Army knives, right? We have to be, coders, developers, programmers, but we also have to be like electronics and hardware guys. We also have to, be statisticians. We also have to be theorists, particle physicist theorists, so we understand why we're looking through our data for certain things. We understand what the effect would be. So we kind of have to do all these things, which means that on the coding side, the programming side of things, maybe our code is not the most elegant code in the world. So I would hesitate possibly to show it to some of the professionals here, because their eyes might start to bleed or something like that. But it does the job that we needed to do. And our data set is in fact quite unique compared to other very large data sets. It's very structured. We do that on purpose, right? Because we want to control all possible uncertainties so that we can be confident whether we've seen evidence of something or rule out that it's a fluctuation of the background of the data, something like that. So the code does the job that we need it to do. That being said, there's definitely a lot of room for improvement in this code. So I think that in terms of practical collaboration, that would be great. And in fact, sometimes we do talk to external experts to at least give us a little bit of advice on what we do. But in terms of really kind of concrete work together, there's not so much. There are professional developers on site at CERN that do a lot of web development and things like that, more with web presence, and also database queries, and also with some of the data management, because we have a very large data center there. A lot of that data management, of course, would require professional developers. But a lot of the old school people at CERN or in particle physics, they are, in fact, left to their own devices. They probably would never have moved away from Fortran. They probably would never have, moved away from basic shell scripting to do everything that they need to do. Now we use more modern things, but there are a lot of, it's one of the key components of any physics education these days. So, younger generations and early career people coming into the field, they definitely have a programming background. They have to, because we have to be data scientists at the end of the day. This is a very large data set. You do have to understand what it means, what data science means. What drives me as a physicist is really, I mean, it almost sounds cliche in a way, that I'm obsessed with the edges of human knowledge. I really am. As a little kid, I was really that kid who would never accept that's just the way it is as an answer. It's like if someone told me that's, it's like, why is the sky blue? Oh, it's just the way it is. I'm like, that's not sufficient. That's not satisfying at all. And so I'm just so naturally drawn to this edge of human knowledge thing. If you're the sort of little kid that never accepts that's just the way it is as an answer, and you keep asking, the questions like the how and why behind the how and why, eventually you end up in physics, and eventually you end up in particle physics, because that's the end, right? You ask a question, it's like, oh, this loaf of bread, how small can I cut this loaf of bread? You keep going, you get to a crumb. Can I cut the crumb? You keep going, and eventually you get to a molecule, right? Can I cut a molecule? Yes. There's atoms inside there. Can I cut an atom? Yes, an atom is a nucleus with an electron going around. Can I cut an electron? And then the answer you get is, we don't know, but as far as we know, no. And that's not satisfying. You're like, I want to know the answer to that. So then you ask, can I cut a proton? It turns out, yeah, there's structure inside of a proton. So you see that when you ask a seemingly simple question like, how small can I cut anything? You're actually secretly asking a much more profound question, which is, what is holding anything together to begin with? And so this is the kind of edge of human knowledge that I'm drawn to, and so many of my fellow particle physicists are drawn to, is we were never satisfied with the kind of stepping stones between those things, where it's like, you get to biology, and it's fascinating, right? I mean, if I had a seventh lifetime, I would study biology, full time. It's like, how did animals evolve? How do these kind of things go together? How do different types of tissues work? And then, get to chemistry. And again, if I had a seventh lifetime, I would study chemistry full time, because that's fascinating too. How do different molecules come together and do these things? But that's not enough for the physicists. We're like, what's smaller than that? What's down below that? Where do you get to the very edge of human knowledge? And that when you get down to the definition where it's like an electron, if you look at it closely, it's probably both a point particle, meaning it has zero volume, zero spatial extent, and it's also a little wobbling quantum mechanical vibrating packet of probability. And beyond that, we don't know. That's where I want to be. If you want the real answer to the question, the reason why I'm interested in questions like this, and addressing questions like, are there multiple universes? Are there other intelligent beings in the universe? Why are the values of all the physical constants and things around us the way they are? Is because I would like to find better ways to convince everybody on the Earth to get along and collaborate a lot better than we do now. Right? Because it's just so terrifying that we see the kind of political and climate crisis trends that we're seeing right now. We're not doing a good job at being stewards of our existence and at collaborating with fellow humans. And if we can put a different perspective on it, if we can say to people, not necessarily like a hippy dippy sort of like we're all star stuff man type thing, which I totally it's fine, but in a more concrete sense, in the sense that we are not separate. We are definitely made of the same quantum field theory fluctuations. If you look at us very, very small, we're all just basically very amazing, intricate, temporary fluctuations in these quantum mechanical fields that permeate all of space, everywhere. And we pop into existence for a few years, and then we go back into the this kind of quantum field continuum. But we're all there all the time, and in that sense, we're all so much part of the same continuum of space-time and the same universe that, again, humanity can almost be thought of as a way that the universe asks questions about itself. So in a sense, the universe is the thing that exists and that has existed for a very long time, maybe the multiverse, and at some point it took about 13 billion years for the universe to finally evolve something to look back on itself.